Find out, I guess. All right, so day 3, we're learning our final method for solving called combination elimination. Right? So I think, have you heard of that before? No? Okay, so this might be a new one, right? The first 3 talked about graphing, substitution, equivalent forms. We're all ones we've done before. Combination elimination, as the name indicates, what we're trying to do is we're going to combine our 2 equations in our set so we can eliminate one of our variables and solve for the other one. Alright? Now, it's most convenient when each is in standard form. So remember we said equivalent forms, if they're both in slope-intercept form, they're both equal to y, or they're both equal to x, equivalent forms would be a good one. If only one of them is equal to one of our variables, substitution's a good one. If neither of them equal one of our variables, it might be most convenient to do combination elimination. How we do that? There's a bunch of fill in the blanks. Step 1, write both equations in standard form. Normally they'll be given to you in standard form. If they're not, and you really like this method, write them in standard form then, where x and y are on the exact same side of the equation. Step 2, wrong way. Multiply one or both of the equations by a constant in order to obtain opposite coefficients for one of the variables. What that means is we're going to try and eliminate a variable. Whether it's x or y, it doesn't matter. We need to get it so they have opposite coefficients, or they have opposite numbers in front of that variable. We're going to do that by multiplying either one of our equations by something or multiplying both of our equations by something so we get those opposite coefficients. Okay, then step 3 is we're going to add the equations together. So once we have those opposite coefficients, we're just going to add straight down our equations so we eliminate one of our variables. Once we've eliminated a variable, step 4 is going to be solve the resulting equation for that first variable, or that variable that is left over. So let's say we're trying to eliminate x. When we add them, all of our x's should go away, which means we're then going to solve for y. That's our first variable. Once you've solved for y, or x, whichever one your first variable is, you're going to substitute that back in, just like we have been doing, right? We found one of our variables, and we plug it back into one of our 2 original equations. And then we're going to solve for our other variable. Alright, so substitute the solution from the previous step into either original equation, solve for the second variable, right? The one that's left over. Am I going too fast? Yes? I can slow down. I'm sorry. Just yell at me. Say something! You can keep going if you want, Miss Larson. That's good. Okay, how about this? Work time. We're going to put you up in front. You can sing the whole thing.
Okay.
Alright. Alright. Are we good? Can I keep going? Or do we still need some more time? Good. Okay. And then your last step, write the solution as an ordered pair. And remember, you can always check your solutions. Your solution should work and make a true statement in both of the equations we're doing this in. So write it as an ordered pair, and then if you would like to, check it. Alright. So, let's look at our first problem. This is your first problem? It's my first problem, right? Cool? Did I get off that screen too fast? You guys good over there? Yeah? Sweet. You guys good over there? Sweet. Okay, first problem, ladies and gents. Both these equations are in standard form. X and y are on the same side, so I'm going to try and use combination elimination, right? If I were to do that, I need to figure out numbers in front of either x or y that are opposites of each other. Well, which variable do you want to get rid of, x or y?
Y.
Y. Why would you want to get rid of y? That's what you picked?
Yeah.
It's actually a really good choice in this problem because if you look, I already have opposite coefficients. I already have positive 2 and negative 2. If I didn't have that, I'm going to multiply the equations by something so I can get those opposite coefficients. Alright? So if I look here, I have positive 2y and negative 2y. Which means if I add the 2 equations, what's going to happen to my y's? They're going to cancel, right? They're going to eliminate. That's why it's called combination elimination. So I'm going to do that. I'm going to get rid of my y's. I'm going to add my equations. 3x plus 8x is 11x. 2y plus negative 2y cancels out. I don't want to do that because I'm going to put some back in there later. But they cancel. Equals 10 plus 12 is 22. So now that I've combined them and I've eliminated an exponent, a variable, I'm going to solve for the variable that's left. Well, how do I solve 11x equals 22? Divide by 11. I'm going to get x equals 2. So that's the first part. Well, what should I do with x equals 2? Plug it into either of the original equations. I'm just going to use the top one. You could use the bottom if you want, but I'm going to use the top. So 3 times 2 plus 2y equals 10. Well, that's going to give me 6 plus 2y equals 10. And from there, it's just solving for y. It's subtracting 6. It's dividing by 2. Right? 2y equals 4. I divide by 2. I get y equals 2. Just put a box around the two of them. X equals 2, y equals 2. No. Write it as an ordered pair, right? 2, 2. Now, if you have time, and it's test day, plug it into both original equations and make sure they come out to true statements. Right? It should always work in all your equations if it's going to be your solution. Okay? That wasn't so bad, was it?
No.
Okay, should we try another? Okay. The next one. Is that your next one, hopefully? Y equals negative 3x plus 6. 4x minus y equals 1. Well, what would probably be the easiest method to use? Substitution. But because we're talking about combination elimination today, I'm going to change it so I can do that. Alright? Now, on a test, I'd say go ahead and do substitution there. Alright? But I'm going to change this top equation so that x and y are on the same side, so I can do combination elimination. So it becomes 3x plus y equals 6. And I have 4x minus y equals 1. Right? So yes, you could use substitution. It'd probably be the fastest way, but combination elimination works as well, as long as you change it up. So I'm going to look. I want to get rid of one of my variables, so I need opposite numbers or coefficients in front of one of them. Do I have it already? I do, Renee. Where? The y's. I have positive 1y and negative 1y. So if I combine my equations at this point, right, if I add them together, I get 7x, y minus y is 0, they cancel, equals 7. Well, then I can solve for x, divide by 7. X equals 1. Sweet, I got x equals 1. Katie, what should I do with 1 then?
Plug it into the other equation.
Plug it into one of our original equations, right? I'm going to plug it into the top one again. Y equals negative 3 times 1 plus 6. Well, negative 3 times 1 is negative 3. Plus 6 would be positive 3. So I have x equals 1, y equals 3. Write it as an ordered pair. 1, 3. Any questions? Those are the easy ones. We didn't have to change anything in those problems. Next ones might be a little trickier. Who knows? Am I good to go to the next one? Or am I going too quick? Okay. 2x plus 5y equals 1. X plus 2y equals 0. Okay. Well, x and y are on the same side, so combination elimination could work. I'm going to try and get rid of one of my variables. Do I have opposite coefficients already for one of my variables? No. So what I need to do is I need to multiply either one equation or both equations by something so I get opposite coefficients for a variable. It doesn't matter which variable you eliminate. Lexi, what do you want to eliminate? X or y? X. Alright. So if I'm going to look at this, I have 2x and I have 1x. I'm going to think, what can I multiply either one or both equations? I can multiply them by some numbers to get opposite coefficients. Yeah?
The bottom by negative 2.
Perfect. I'm going to multiply my bottom equation by negative 2 because I already have positive 2x up here. If If I multiply 1 by negative 2x, I'll get negative 2x. So I'm left with 2x plus 5y equals 1 for my first equation. And then negative 2 times x is negative 2x. Negative 2 times 2y is minus 4y. 0 times negative 2 is 0. Now be very careful. When you multiply one of the equations by a number, it needs to multiply by each piece in that equation. We're not just multiplying the x value by it. We're multiplying every single piece. X, 2y, and 0. Alright. Do I have opposite coefficients now for x? Yeah, so now I'm going to add my equations together, and I'm going to eliminate my x's. 5y minus 4y is going to be y. 1 plus 0 is not 0, it's 1. So I get y equals 1. Alright. What should I do with y equals 1 then, AJ? Plug it in to either of my original equations. Doesn't matter which one you choose, just got to go into one of them. Johnny, which one do you want to plug it into? Top or bottom?
Top.
Top. Alright. 2x plus 5 times 1 equals 1. 2x plus 5 equals 1 minus 5. I get 2x equals negative 4, so when I divide by 2, I get x equals negative 2. Should I leave my answer like that? No. Write it as an ordered pair. Negative 2, 1. Alright. Any questions so far? No? There's a fourth one. Right above it, it says you try. So why don't you guys try that other one? Alright? You may have to multiply both of your equations, by something. Oh, what's going on there? No? We'll figure it out. Okay. Guys, you do not need to multiply both equations by the same number. You can multiply your equations by different numbers if you'd like. Alright, but I would think this problem you have to multiply both of them by something. Remember, you're looking to get opposite coefficients. There are multiple ways to go about this. So if you and your desk partners don't do the same, that's perfectly fine. Just still get the same answer though. If you're struggling, please raise your hand and ask a question. Okay, what's up? Well, let's first look at
No, I
I can't read
what
this.
number do you multiply? We multiply 2. It's 4 and what number do you 4 and 3? They go in 4. Well, so what am I multiply negative 3 by negative right? 4. Multiply this by 3 and then okay, that makes sense.
I did too, I just subtracted it all.
Okay.
Yeah.
And then trying to fill out the whole
Same question?
Like there's 3.
My brother
I did this differently. So
it's impossible.
So you guys ready to answer?
And so much of it is like,
Can you guys ready to answer?
oh,
Right answers? Nice. Hey, how you doing? Good. You have a question? Oh, this is nice.
Insane.
Hey, how's it going? Good question. No? Okay. How'd you guys do? Or how are you doing? Good? Okay.
they're literally
Do you plug this into the?
so hot, very unique.
They're really running out of work.
So,
That's water.
No,
Like
I
that's
can't hear
water.
it.
That just tastes gross.
I will not be there this Saturday. I have a prior engagement, so I'm not gonna miss a lot. I'll be there on Tuesday. Alright guys, hey! How do we do? Good? So-so? Good, so-so. Did you get the right answer? Sweet. Hey, any questions on this problem, or do I need to give you more time, or some people still working on it?
More time.
Does anyone besides TJ need more time? Question?
Okay, so I multiplied the bottom one by negative 2.5.
And then you got, so this would be -5 then?
Yes,
But then you end up with like decimals over here?
yes, but then it you still get y equals -2.
Perfectly fine.
But will that work on like other ones?
You might have to deal with decimals or fractions then, but you should still get the same answer. Okay? Alright. Any questions? Sweet. Maybe a little more to talk about, don't we? Special cases. So, how many answers did every single problem we've done so far have? Well, it had one solution, but it had two parts. Right? It had an x and a y. Right? So it had one solution, it had one answer to its set. That is true for most systems. Sometimes there are no solution. Sometimes there are all real numbers, right? Any possible solution. So, when that happens, if it's going to have no solution, here's what you can look for. There's two different things you can look for. If you're solving it on a graph, and you look and you see, well, they're parallel and they don't intersect. I think we talked about this. Right? If they don't intersect on a graph because they're parallel, there's going to be no solution. Or if you're solving it, and your variables all cancel out what you're solving, and it's a false statement, that means it's going to be no solution. There's no number known to man that you can plug in there that's going to make it true. So if they are parallel on a graph, then there's no solution. If the variables cancel out and it's false, there's no solution. Now, for an infinite many solutions, the graphs will be the same line. We talked about that before too, right? If it's the exact same line when you graph both of them, it's going to be infinite many solutions, or infinite number of solutions. Or if you're solving and the variables cancel out or are eliminated again, and it becomes a true statement. That means any numbers you put in there are going to work. So it'll be infinite many solutions then. Alright? Any questions? Can I keep going? We good? Good. So if you want to know how many solutions each one's going to have, you can kind of look at this table, right? If they're different slopes, then it's going to be one solution. If they're the same slopes but different y-intercepts, that means they're parallel, they don't intersect, that's no solution. If they're the same slope and they are the same y-intercept, that means they're the same line, which would be infinite many solutions. Am I going to ask you to regurgitate this graph to me on a test? Absolutely not. But it is a nice little key for you to look at if you would like to. Okay? Cool? Alright, we have 2 problems left. Let's cruise through them. Okay? You good back there? We good to go?
Yeah.
Okay, let's do it. So, 3x plus 2y equals 10. 9x plus 6y equals 6. So I'm going to do combination elimination because they're both in standard form already. I'm going to get rid of, let's say, y first. I have 6y. What can I multiply 2y by to get negative 6y? Negative 3. When I do that, I get negative 9x minus 6y equals negative 30. Well, if I go to combine those, 9x plus negative 9x is 0. 6y plus negative 6y. 0 equals negative 24. Is that a true statement? No, right? Notice all my variables cancel out. It is not a true statement, which means my answer is going to be no solution. Right? If all your variables go away, no x's, no y's to be seen, and it is a false statement, that is no solution. Let's look at the second one. 5x plus y equals negative 2, negative 10x minus 2y equals 4. Let's try and get rid of x over here. I have 5x and negative 10x. What can I multiply 5x by to get to positive 10x? 2. So I'm going to multiply this whole thing by 2. 10x plus 2y equals negative 4. I go to combine and eliminate. Negative 10x plus positive 10x is 0. Negative 2y plus 2y, 0 equals 4 plus negative 4, 0. Does 0 equal 0?
Yeah.
Yes, infinite many solutions.
You have to write infinite or you do?
Let's think. I would accept infinite many solutions. I'd probably accept all real solutions. I wouldn't accept just many solutions, but like infinite many or all real solutions would work for me. Does that make sense? Does that work? Okay. All right. Sweet. Any questions? Speak now, forever hold your peace. Just kidding. You can come ask whenever you want. All right. Sweet. Homework time.